from this state space representation of a system, find all these things. We're going to go through this. By the way, in our old notation, this is the A matrix, D matrix, C matrix. D matrix, our scalar, is just 0 space. So let's find all these things. The characteristic equation, and from there, the eigenvalues are the same thing as the poles. Transfer function, corresponding control canonical form and observer canonical form, state transition matrix, solutions for x and t, one when the input is 0 and one when the initial state is 0. Same for the output for this second last case. By the way, once you have G, H should be easy, right? You have the whole state when this is the case. Now you just want the output, same case. This is how the output relates to the state. So you're just taking the top state. We'll get to that at the last step. By the way, as you go through this, you would probably need a formula sheet. Again, this was the A matrix. A matrix. Here's the formula for, well, this determinant set to 0 gives you the characteristic equation. Si minus A, this would be S up here, S plus 5 down here. Switch these guys' signs. Take this determinant, I get S times S plus 5 minus a minus 4. This, there's our characteristic equation. That factors, so our poles are at -1 and -4 on parts A and B. Transfer function. We had this formula from a formula sheet. In our case, the D is 0, so we just need to do this matrix arithmetic. A, C. So we need to do this Si minus A inverse. Here was the Si minus A. We did that in part A. Si minus A. Here's what's inside here is Si minus A. Inverse. Remember how to take an inverse? Well, we take that determinant, divide by the determinant, which we also found in part B, I guess, A and B. Determinant, or this inverse, for a 2 by 2, I switch these two terms on the main diagonal, change the signs of the off diagonal. It's Si minus A inverse. And I need to, what do I need to do? 3 multiplied by C and plus multiplied by B. Here is C. Here is B. So I have to do this matrix multiplies. First one will be, let's see, that's plus 5. 0 because that's 0. This will be 1, 1 plus 0. That's this first part. And when I just add them up, I'll have S plus 5 plus another 1. Here's our transfer function. Corresponding control canonical form and observer canonical form. Need to multiply this denominator out again in this format so I can match these coefficients. The formula sheet would come in. So my B1 is 1, my B0 is 6, B0 is 4, B1 is 5. Put these in the formats. You'd have to go back to the formula sheet to see how that works. I'm not going to go through that. It tells you where all the A's and let's see, the state transition matrix. X I minus A inverse, and then we take its Laplace transform. We have to take this inverse and then take the inverse Laplace transform. We need to do it term by term. We've got to do a fair amount of partial fraction expansion for each term. I'm not going to go through that. this top left one, for example, is this. Breaks up, you can use cover-up method in these cases. And cover-up method would give you the 4/3 here and a minus 1/3 there. These are easily looked up in the table. This is inverse Laplace transform stuff. I won't go through that in detail. This part's a little bit tedious. Here, ultimately, when you put it all together, is the state transition. Find the state when the input is 0, initial condition is all ones. When the input is 0, we can find all that out from the state transition matrix. Here's the state transition matrix. All we do is multiply it by the initial state, and it said it's all ones. Yes. Now I'm just doing this matrix multiplication. It'll be this plus this. Matrix multiply. You do that, you get this. That simplifies a little bit. We're only interested in the output. For another little matrix multiply, or just pull off this top. I don't know if they asked for that, but there it is. Okay, what about find the state when the initial state is 0, but the input is a unit step? We would get this from the formula sheet. Formula. We had our SI minus A inverse already in the B. U is a unit step, that's 1 over S. So I need to do this matrix multiply and take the inverse Laplace transform. This 1, 1 just means I add the elements in the rows. When I add these two guys in the top row, I get that. When I add these two guys in the bottom row, I get that. Then I have to do some partial fraction expansion. I won't go through that in detail. Take the inverse Laplace transform, I get this. Do the same for the bottom row. Put it all together, I get this. Yeah, this is another little, takes a little bit of tedium of all that partial fraction expansion and then inverse Laplace transform. And then what is the output under those same conditions? Well, that's easy. We already have the X. Y is just basically the top row of X. And we're done. Done with that example. Next up, controllability and observability.